Welcome back, everyone. In this lecture, what we're going to be doing is creating a prediction function, essentially continuing right where we left off last time and creating a function that takes in a model, a scalar, and then the actual data set to be analyzed and returns back a prediction based off the model. Let's go ahead and continue in the same notebook as last time. Okay, here we are back at our notebook. When we're talking about deploying models, really what we're talking about is exchanging data. We're going to need to accept data in some sort of format and then have it be processed through our model and then return that data, and that data will then just be a prediction. So it's very typical that JSON is used for this data interchange format, and JSON stands for JavaScript Object Notation. And if you've ever worked with any sort of web app or any sort of API, you should probably be familiar with JSON. Even if you're not really familiar with JSON that much, it really looks so similar to a Python dictionary that it will quickly make sense to you. So what I want to do is first show you an example of what the actual data object we're sending to our prediction function is going to look like. So we'll say flower example, and essentially what this is going to look like is a dictionary, and we're going to be using double quotes here, and there will be a key value pair for everything here. So what I'm going to do is, if I take a look at, let's make sure the cell type is code. Cell type code, I want to first insert above, and if I take a look at iris, let's take a look at the very first example. So we'll just say head of 0, or head of 1. So one row here. What I want is just to show you what an example data point would actually look like. Recall that we only need the features, so some researchers out in the field, they're going to mark down these features. So later on, what we're going to be doing is sending a JSON object that will look something like this. So here we have sepal length, then we'll have sepal width. We'll go ahead and give those values as 3.5. So I'm just grabbing these values from the first row in our iris data set. Then we'll say, double quotes, petal length as 1.4, and then finally petal width, and that'll be 0.2. Notice here I'm not passing in the species because in the real world situation, the researcher picking flowers out in the field is not going to have access to the species. That's what the model is for. So here I have my flower example, and although I have it here as a Python dictionary, this is essentially exactly what the JSON object will look like. So what we need to do is create a function, and we'll call this function return prediction. And this function takes in an already trained model, a scalar if necessary, and then some sample JSON string to predict off of. And eventually what I want to return is my actual prediction. So first thing I need to do is grab all the information off of this JSON object. So I'm doing a little bit of duplication work here, but essentially what I'm going to do is say s length for sepal length is equal to sample JSON. So recall, this is going to be the sample JSON that's passed in, and then we expect it to have a key of sepal length. And later on when we're actually deploying these, we'll show you how to make sure the key names are correct. And the next one is sample width. So it's again sample JSON, and here it's sepal width. Then the next one is going to be petal length. So sample JSON, then go ahead and ask for petal length. And then finally, petal width. We'll say sample JSON and ask for petal underscore width. And essentially what this is doing is it's breaking out the individual components from your JSON. So you can imagine that if you had a really complex data set with tons of features, you would be breaking off a very large JSON. And if it gets really large, you could try using a for loop to try to loop through those keys. Okay, so we now have our 4 separate components. So let's build out what an individual flower would look like. I'm just going to assign it as an array because that's the way the model expects it. So we pass in this single flower with the measurements from that sample JSON. And then what we need to do is transform that flower, essentially scale it. So we say scalar transform flower. Recall here that I'm passing in that scalar, which is the scalar that eventually I will load up here, as well as the model. So we scale that flower. Now it's ready for our model. So what we're going to do is say class index is equal to model predict classes from the flower. So if I were to take a look, let me put a new cell here, at my encoder, recall that the actual encoder, let's make sure we fix that typo real quick, make sure that the actual encoder, recall, has classes associated with it. So the encoder classes are Setosa at index 0, Versicolor at index 1, and Virginica at index 2. This essentially lines up with what we transformed Y to be, which was this one hot encoding. So recall I mentioned that we were going to tell you how to understand what index position lines up with which class. Well, all you need to do is call the same encoder that we used, and then call this classes underscore attribute, and it lines up the actual index locations. So let's go ahead and just grab this array right here. And since we're not actually passing in this encoder, since that's different from this scalar, what I'm going to do is say classes is equal to this NumPy array of Setosa, Versicolor, and Virginica. So I have this classes, and now I have this class index, because the model, when you pass in an actual predict classes on the flower, it just returns an index 0, 1, or 2. So what I'm going to say here is return, and let's first see what happens if I were just to return my class index. Well, let's say return prediction on my flower model with my flower scalar and the single flower example. So I run that, and it returns back this array of a single item. So if I just grab index 0, the first item off of this, rerun both of these, then it just returns 0. That returns the actual index. So what I should probably do here is put a 0 there so that I actually get the class index instead of an array holding the class index, which means that I can say classes at the class index. And now running this, it returns back Setosa, or whatever it happens to predict based off the measurements I passed in. All right, so what I'm going to do is in a single cell, put everything that we need to take from our working notebook for deployment. Recall that notebooks are really great for working with data, visualizing data, training models, and then editing your model's hyperparameters. But when it comes to deployment, I can't really deploy based off of a notebook the way I want to with an API and a Flask application. Since this notebook is running in a browser, it'll start to kind of almost fight with the actual deployment process. What I'm going to do is, here we'll say code for deployment in a markdown cell, and I'm just going to type all the code out necessary for deployment. A lot of this will just be copy paste. First, I need to be able to load up my model and load up my scalar. So that will be the 2 lines we did earlier from TensorFlow.keras.models, import load model, import job lib, and then we'll go ahead and copy these 2 loading commands. So we'll load up the h5 file, as well as loading up our scalar file. Let's go ahead and grab this pickle file here. And then once you've loaded up your model and your scalar, you just need this return prediction function. Grab that, stick it in here, and this is essentially what we need for deployment. We need to be able to have the correct imports to load up our model. Another thing we might need here, since we're calling NP, is say import numpy as NP, and any other sort of classes or calls you use, you may need to load them up, but it looks like we should be fine based off this. Okay, so we have our imports, load up our model, load up our scalar, and have a function that takes in that model of scalar and the example features, and then reports back the predicted class. This is all the code that we're going to be transferring over when we actually run this as a Flask application that accepts an API. Thanks, and we'll see you at the next lecture.